Now, I just said that we're going to start building things, but before I do, notice I just pointed out that our current migrations are all configured, written, I should say, to work with SQL Server, right? And in fact, when I come back to program here, you notice that our DB context says .use SQL Server. However, I'm going to start off the course right away using SQLite instead of SQL Server, right? We're talking very soon more about SQLite, and I'll be explaining why and the reasons for it and so on and so forth a little bit more. It has some drawbacks and it has some strengths. One of the main strengths is that it's totally free for us to use, even up in Azure, right? So we don't use any of our precious credits as students by using SQLite. So to get it installed, I can just come down here to the NuGet Package Manager, use the Package Manager console. I know you've been here before, and I can just come in here and go install package, right? I don't need to take time showing you the Intella or the tab completion. That's help is available here. Microsoft AnyFramework Core SQLite. Notice, of course, I am copying from my my little copy paste file, right, that I have available, and of course I've made available to you as well, right? Okay, 9.0.8 all installed. Very good. All right. Okay. Actually, that reminds me though, let's just check something. I didn't show you one file I didn't actually show you. If I double click the project here, here is the properties of the project itself. And have a look at this, okay? Notice that SQLite is 9.0.8. Most everything else, the other one I point out is tools. The tools package works with both SQL Server and SQLite. Notice that the version number of everything else is quite a bit older, 9.0.4. Wow, not that much older. Actually, things would run fine, although I would probably at some point get a warning about my tools being out of sync with my actual SQLite. So there's several ways we could go about fixing this. I could have specified the version, could have looked here and decided, okay, I'm going to stick with 9.0.4 and specified that version when I installed SQLite. But I think I'm safe to just update everything. So it gives me a chance to show you this as well. If I come in, instead of using the console, go into Manage NuGet Packages for Solution. This gives me my interactive dialog box. And we've been in here before. I've often gone to Browse to look for things and so on. But if I go to Updates, notice it's identified. Look at this. There are 5 packages here that are all older, right? That are 9.04 and could be updated to 9.08. So I'm going to check off, select all packages and update. Yes, I'll apply. Yes, I accept. Yes, I will sign away my firstborn son to Microsoft in thankfulness. There we go. No more packages, and everything should be back up to the same version here. I can close this, and look at that. It's already updated here. 9.08 for all these. Now, let me warn you, you won't always have the same version number for everything inside of here, right? We're going to be adding some tools that are not in the same stream of development as these Microsoft ones, and they'll have version numbers all over the place. So don't always expect all version numbers to be the same. But I just thought I'd share that with you since we had a difference in versions there. Okay, all right. And I said if we didn't have that tools package already, we would definitely have to add that as well, because that's where our migrations come from. All right, so we're ready to actually start building. So let me just right-click, close all tabs. And I want to come over to the models folder. So I'm going to start off by creating a class. Now, something I want to emphasize, this was talked about in our PowerPoint as well, right? But there's a series of tools or approaches that we use. Number one is naming conventions. We do as much as possible with naming conventions. If that doesn't take care of an issue with how we want to build our models, then we'll go to data annotations, right? And if there is no annotation to do what we want to do, then we'll use what's called the Fluent API, right? So I'll review that again as we use each one, but let's just start off by adding a class. So I'm going to make a class here simply called mask. Remember, these entities or classes, our models, should always be in the singular form. So don't say with a plural there, right? It should be mask, right? Okay. So if I come in here, prop, tab, right? I'm going to have an int called ID. Prop, tab. By the way, there are other choices. I've shown you that before. If I go prop full, then I get the full separate setter, getter, and everything else in a private variable created. This is the short form for a property. And you know what? I mentioned it once before that these are what we call POCOs, plain old CLR objects. We do not get into writing a whole bunch of code in the setters and logic like you've been doing in your object-oriented programming classes, right? No, we leave that to other areas in the application. Our entity models should be very, very simple, right? Okay, now I'm going to put a question mark here because I do want to make it a nullable string. And as you know, in the latest versions of .NET, it's gotten away from having strings and other complex properties nullable unless you specify that you're going to allow that by default. I'm going to have one here called mask type. And I notice I can just tab to get to the end and press enter and so on, right? Okay, so just to save some time, I'm going to throw in the two more that I want to have, just with a bit of copy paste. All right, so there we go. I have another nullable string for the description and a required double, okay, for the price, right? So that's my basic mask, right? Now, so that gives me my model. Remember we said there is this application DB context, but we're going to create our own. So in the data folder, I'm going to right click, I'm going to add a class. I'm going to call it mask context. Again, stick to these, naming conventions. All right, I don't know how I got an extra character there just on the keyboard somehow. Okay, and rename the file as well. Okay, fix my typo that way. All right, so inside here, I'm going to need a couple things. First of all, I'll need the constructor because the database will need the options that I require. Oh, wait a second, what's this? All right. It's because I forgot to specify that I'm inheriting from DB context. Okay. Notice it automatically added a using for me. Sometimes you have to manually do it, just, it'll be underlined in red and the little helper will say, hey, add the using, but it already added Entity Framework Core right there. Okay, so now my constructor is happy. So what I really want now is a DB set. This is part of that entity framework system, right? So what is a DB set? Basically, it's a collection of objects of an entity with superpowers. It's kind of like our repository system, right? It's part of that it hides the complexity, so it gives me simple methods like add, edit, and delete, and so on, right? Or that type of thing. So with Entity Framework Core, this is how we get that functionality in place without having to program everything manually ourselves. All right, so there's our DB context, at least the basics of it for now. Okay, let's come back down to program.cs. Remember, here is where we add, first of all, we get from our connection string from app settings, right? And then we get that and we use that as we build our DB context here. So we need our own DB context, my mask DB context, so I can inject it wherever I need it. I'll put it right below this one, okay? Notice I have it set to use SQLite, right? This one still says use SQL Server, but that's okay. We can fix that. Use SQLite. All right. Trouble is, though, my connection string is written for SQL Server. So let me come back to app settings then. What I could do is I could come in here and actually just replace it altogether, or I'm going to comment it out. So if just in case later on I did want to switch back and in my demo show you how to work with SQL Server as well, I'm going to leave that there, and I'm going to come down here and add the very, very simple style of connection string we need for SQLite. Okay, all we do is we specify file name. So I'm just going to call it maskdatabase.db. Now it is true, I'm just sticking with default connection. We can have multiple connection strings, and technically I could have a separate connection string and essentially a separate database for application DB context, which is the security system, all the logins and passwords. I could keep that completely in a separate database from my actual production entities and tables for my mask contacts. But I'm going to take the route of having it all combined in one. So I only need one connection string, and both of these DB contacts will use the same common connection string that I'm pulling from my configuration, my app settings JSON file right up here. All right, so let me just do a quick build, make sure I haven't messed anything up. And okay, rebuild all succeeded. All right, so I'm ready. I'm going to clean up the screen. I'm ready to come into the Package Manager console. And I need to create a migration. So down here, I'm going to add migration. Dash contact. Now, I wouldn't have to say dash contacts, except that I have two. I've got two different contacts, application DB contacts and my mask contacts. So I do have to specify which one going forward all the time. I could just leave it as that, but I want to specify the output directory, right? Remember, right now, the existing migrations that were originally there are under data, right? So I'm going to specify the output directory would again be data, but I'm going to make a /FM for face mask migrations, right? All right, now I can press enter now, and it will prompt me for a name for the migration. I could have just gone space and had that right here on that line of code, right? And that would have accomplished it without me having to type it in separately. So build started, build succeeded, and here we go, right? So we see up here under data, here's my new folder, FM migrations. Notice the timestamp, okay, shows the actual time that I'm doing this recording, right? And then the name is initial, right? So, okay, that's good. So let's have a quick look here. Create table masks, okay? ID, column integer. Notice that it's SQLite auto increment. So this is all written with the proper data types that SQLite supports, right? Constraints, the primary key, okay, is the ID, right? That's something I want to talk about a little bit more before we go on. But let me just point out that the down simply drops the table. Okay, all right, that's good. So how did it know that the primary key would just be ID? Once more, yet again, there are three rules, right? Naming conventions, data annotations, and the Fluent API. So coming right to the mask model, there's a naming convention for the primary key. I can either use the entity name followed by the letter ID. So I could have gone public int mask ID, and it would have assumed as well that that should be the primary key. Or instead of the entity name ID, I can just use the letters ID. And it doesn't care whether I use capital letters ID or a mixture of capital and small, right? It doesn't matter. The naming convention works either way. Just be consistent in how you've used it and you're fine, right? So public int ID, and that's how it knew that that should be the primary key, right? By the way, when we get to having foreign keys, that's one reason why it works very well, having just using ID as the primary key. There's a couple reasons. One is then when we go to make a foreign key for the mask entity in some other class, we would use mask ID then for the foreign key. And that's a nice consistent approach. The other thing is sometimes we inherit, right? You might have, for example, a person class, right, that has a primary key of ID, and then you have a whole bunch of other classes for employees versus customers and so on that all inherit from person. So the common things about first names and last names they're getting from the person class. Well, in that case, it always works best if the primary key of the class you're inheriting from is just simply ID. Just trust me, makes life easier going forward. So I just want to point out then that's how the naming convention worked, and it knew that that property would be the primary key. All right. Now, before I go on, I just want to point out we still have this migrations, right? The initial one created for our application DB context. Well, it's written for the wrong database now. Easiest way to solve that is delete it, right click, delete the whole folder. And then if I come back to the Package Manager console, then I'm going to do exactly the same type of thing I did a minute ago, right, for my own DB context. By the way, a nice thing about the Package Manager console, I can use the up and down arrows to go over previous commands, right? So there's my add migration command. So here I can say application DB context. And output directory, I'll just use the same name that was there, migrations. And I can call it initial, I can call it whatever I want. Okay, there we go. So now under migrations we see, okay, now notice this time it has a proper timestamp, but let me point out over here, yes, we're creating all the same tables we were before, but the data types have been changed to work with SQLite, right? So it's important that I did that. Down the road, now I probably in this demo won't even get around to using the identity system, but you know, I hate to leave something like that hanging, right? Okay, all right, so we have everything in place now that I could start creating. Oh, sorry, one thing I missed, I need to actually create the database. So I have to do that with one more command, right? I have to say update database. Tab completion update database. And it'll be my, oh, sorry, didn't mean to click. Context, mass context. Okay, so finally, if we look carefully here, we can see some of the code that was executed. And sure enough, yep, create tables, create table if not exists, and so on and so forth, right? Here's my table masks, ID, and so on and so forth, mask type, and so on, right? So yeah, now it's finally executed some SQL for me, right? And if I come over to the side here, there is my database. How can I look at it? Well, in our labs, we have a tool here we've installed called the SQLite SQL Server Compact Toolbox. And by opening that up, I can click the little plug here, connect to what database it sees, my mass database. I can expand it, tables view. So there's my mass table, right? And there's all that like triggers, indexes, and so on and so forth. Okay, I can even right click on it and say edit, top 200 rows, mass type. I don't know, N95, description, best one there is. And price, I don't know, $29.99. Hey, it's during the pandemic, right? We get to gouge people, to charge whatever we want. Okay, so I've actually entered a row of data into the database itself, right? All right. So by the way, in my copy-paste file for the medical office demo, I actually have the link to go and get this tool if you don't have it at home, but we already have it in the lab already. Okay, all right. Now that I have that and I've created the database, let me come to controllers, right click and say add controller. I want an MVC controller with views using entity framework. Okay, add. Now here, I have to choose the model class, my mask model, and of course which DB type, or DB context I should say, the mask context, right? And that's configured from the DB context, so we don't specify that. I'll leave all this checked, but please remember this going forward. Do me a favor and yourself a favor. The system automatically takes whatever your model class is and pluralizes it for the name of the controller. but we don't want that. We want to have it the same as the name of the actual model class itself. So take out the S. Remember, do that every time, right? S or however other ways that it actually pluralizes it, right? The reasons for that will come clear more later on, but let me tell you, it'll just make life easier if we make that change to the approach right now. So I'll click add, and it takes a moment. It's got to do some scaffolding and so on and so forth. Building, and bada bing, bada boom, generating code. And it's going to create my controller, plus, because the option I chose, it's also going to create all the views, right? So here's my mask controller. And down here under views, okay, here are the mask views. And notice index, edit, details, delete, create, right? Okay, 5 views. So not surprisingly, in the controller, we see a bunch of actions here, right? Let me just go Control MO to shrink everything down. So you can see the structure here. Mask controller inherits from controller, right? There's our constructor. We'll come back to that in a minute. But we have index, we have details, we have 2 creates, 2 edits, and 2 deletes, right? Well, delete confirmed, but it's basically just a delete. You might say, well, why are we have pairs? Why do we have 2 each for create, edit, and delete, our actual database operations? Well, the reason is, right, as a rule of thumb, in any web application, you should not update data or change data on a GET request. It should always be on a POST. So these are all paired. The first one responds to a GET request, right? So basically, it just gives us the view itself. Then, after so for a create view, we'll see it'll have all the fields to fill in and so on. And then for the POST, and we mark it here, we annotate it with HTTP POST. So if it comes in the action specified as create in the route, and it's a POST, then it will be sent to this action inside the controller. And here is where it will actually go in to our context, add the mask, save changes, and away we go, right? Same idea with edit. The get just basically gives us a blank page with the actual mask data filled in for the mask that we chose to edit. How do we know which one? We pass the ID of the mask we want to edit. Down here is the post, so here is where we would take the information that was maybe changed and actually update the mask, right? Don't worry, we're going to talk more about how all this code is put together. I'm just showing you the pairing of the get and the post that are used for the whole process. The get initially just gives us the information on the screen, blank form or a form to edit, whatever, and then the actual database operation is carried out always in a post. Okay, all right, let's come back to the top now. So we have our controller, we have a read-only, okay, private variable for the actual mask context itself, just named _context. In the constructor, here's how we get that. As we construct our mask context, look, from dependency injection. Where's this coming from? Program CS, right here, where in services, we added this DB context called mask context. So that's why we can just inject it in as we construct our controller. We say, here you go, here's your context. Use it to do all your work in the database itself, right? Okay. Index is pretty straightforward. This is maybe the first link query you've maybe seen. All right. Well, no, I showed you some the other day, right? So we're just going to our DB context. Now this is just using extension methods, .masks, .toList. Now, of course, everything is, as much as possible, we usually want to go asynchronously. So it's toList async, right? So this is an example of an actual link query. It's just going to go to the database, basically select star from masks, you might say, and then build all the mask objects. And that's what we supply then as the data to the index view. Wow, let's have a look at the index view. Here we go. Look at that. There's a model directive, C# razor here at model. What is the model for the view? It's a strongly typed view because it has a model. IEnumerable maskdemo.model, so fully spelled out namespace .mask, right? So that's the actual mask model here, right? Which of course you see is the namespace maskdemo.models. Okay, so now it knows what is the type of object that it is based on. there's our view data to provide the title, okay? It's an index, so we're going to list all of them. So not surprisingly, after a create new link, we have a table, right? In the header section, we have 3 columns, actually 4 columns defined, okay, with this nice nomenclature here, display name for the mask type. Notice the lambda expressions because it requires a lambda. Mask type, description, and price, okay? But these are the display names at the tops of the columns. Then in the body, we have a for each loop for each item in our model, in our IEnumerable collection of masks. We have display for the mask type, description, and price, okay? This last column, which the header was empty, contains links for edit, details, and delete, right? And we'll talk more about those in a moment too. Okay, but that is the basic structure of our index page and how it works with the collection of masks being provided, okay, by this link query to the view, and away we go. So let's run it. Now, I don't have it in my menu system yet, so I'll fix that next time I stop. So I just go mask, and then the default will be index, so that's good enough. There we go. Here's our index. There's that record I manually added in the database earlier, right? But if I select edit, okay, you see the path up there is mask/edit/1. 1 is the ID, not surprisingly, integer identity, that was created for that particular mask record. And here I could modify the data. Best one there is hands down. And you know what? The price just went up as well. There we go. I can click save. And we're back at the index, but we can see that our changes were saved successfully to the database. I can create new, back to the list, go to details. I just see all the details there. And I can select delete. No, I don't want to delete. It's my only one right now. But if I create a new one, mask type cloth. Basic, but helps. And price, hey, it's still going to be inflated, right? There we go. And if I wanted to delete, are you sure you want to delete this? I'll say delete, and away we go. Okay, so there's a demonstration of it actually running, going through all of the process itself. But, you know, I should have pointed out a few issues here while we were working, right? For one thing, you know, darn, I forgot to do it. I know. This is my, oh, not home index, mask. Mask index. Okay, look at that column heading. There's no space between mask and type, right? Not very good at all, okay? And that's the same problem here on the details and so on, right? Because we didn't supply display names, so it reverts to just using the name of the properties themselves, right? Well, we can fix that quite easily. What we're going to do now, there are many reasons why we would want to come back to the model, right, for our mask model, and say, you know what, I can provide more information to the system. Remember, we don't muck around in the getter and setter in these simple POCO, plain old CLR objects, but we do have annotations, right? So for example, you know, I've made it a nullable string, right? So I would be allowed right now, I should have shown that, but if I created a mask and didn't supply it, it would allow me to do that. I would just have a blank or a null for the actual name itself, right? But let's say, no, I want that to be required. Well, one way I could do that, even without changing the string, the question mark, I could say required. And spell it right, might help, okay? Now, it's underlining, saying, wait a second, we have to add using for system component model data annotations. Data annotations are our friend. Even if I made it required by not putting this, but getting rid of the question mark, right? That would be a partial solution, but this is even better because of this. Let me show you. As well as saying required, I can provide a whole bunch of other things. I can say, hey, here's an error message. The type of mask is required. Name the type of mask is required, right? Okay. And, how about the fact that mask type is not a very user-friendly thing to appear on the screen? Well, another data annotation. I can say display name, the display name, type of mask, right? Okay, what if we want to put a limit to how long the text can be entered in here? It just seems reasonable, right? Let's say we're going to set a limit of 64 characters. Perhaps that was actually even provided to you, right, as you were given guidelines as a developer, right, that they wanted to limit it to that. Well, then I can say string length as a data annotation. 64, error message, right, mask type limited to 64 characters. Okay, there you go. And that would be fine. So I can do the same kind of thing here for the description. I can say, guess what? I want the description to be required. You cannot leave it blank. If they go over 256, I'm just going to say description is too long, right? How about the price? Ooh, we can do quite a bit here too, right? Notice it already is required by definition. A double can't be null. But now we can provide an error message too. You must enter the price, right? Data type .currency. We'll see in a moment that it automatically get nicely formatted for us, right? Column type name, okay? That is something that is specifically for the database itself, right? Actually, that's more applicable, to be honest with you, to SQL Server, but it won't hurt us at this stage as well. Let me just try to run it. I did it again. All right. I'm going to make that change. Let's come down to Layout under Shared. Here's our menu system, right? So I'm just going to steal one of these. Oh. Set up this one. I'm going to steal it. So the controller will be mask. Action is index. Now here is where I can say plural, masks. Okay, so I'll just save that, do a hot reload, and there we go. And there's masks. All right. So now you see it's nicely spaced out there, type of mask. If I click Create New, click Create, there are all my nice error messages showing up. The name of the type is required. You cannot leave the description blank. You must enter the price, right? So if I put something in here, see it goes away right away, and so on and so forth. Now that's happening client side, right? As much as possible, it will try to do everything client side. Some things, though, for validation, we have to wait till we get to the server, and then it will redisplay the view with the error message if we're violating some kind of a validation requirement. But, it's really nice when it can do it all client side. Just be aware you won't always have that luxury. Okay, I'm just going to go back to list for now, right? And away we go. All right. So I've made some changes to the model. So let's just go back into the Package Manager console. If I use the up arrow again, here's my add a migration for my, I want the one for my mask context. I don't need, for our subsequent migrations, I don't need to specify output directory. Once that's done, once it's set. I don't know. Changed mask. Okay, a little warning there. Might result in loss of data. That's because of the things like the restriction on the length and so on. Okay, if we had data that was maybe more than 64 or 256 characters, it's warning us we could have lost data, right? But it looks like it's ready to go. So we're altering the double column, okay, changing its type there, right? The mask type, we're setting the requirement that it's no longer nullable and that it has a maximum length and so on, right? And the down would just reverse it back to the previous way it was. So I can update my database for my mask context. And there it goes. Okay. All right. So now it's made those changes in the database as well. So we've had a chance to see a successful migration. And now looking under data and under FM migrations, face mask migrations, there's our initial one, and there's our change one, right? As we get more and more, and I can just roll back to an earlier one if I wanted to with a simple command in the Package Manager console. All right, well, that's good. But you know what? We've thought of an even better idea. Well, I better stop and start the recording, though.